CI/CD pipelines and basically propose a completely new approach to develop our applications, to deploy them and to observe them in production, to prevent issues from happening, and also to build proper database guardrails in our apps. So the agenda for today is, what we're going to do, we'll go through a couple of big steps. So we'll see how to integrate application with Metis, how to improve CI/CD pipeline, how to introduce database observability and build some understanding of databases behind the scenes, how things work and whatnot. So let us begin with actually, before we move on to integrating everything with our platform, let us begin with the problem statement. What do we want to do? So the typical way we develop our applications is we write some code, we then deploy things, we do use some CI/CD pipelines, etc., and then we push things to production and see whether it works, right? However, things may break along the way. Hopefully, we have unit tests, we have end-to-end tests, integration tests, or whatnot, to catch those issues, to spot the bugs before we deliver to production, right? The problem is that our applications, when they interact with databases, they may not necessarily work well when we are talking about the scale, and also when we are talking about how things work behind the scenes. Meaning that we use ORM libraries, we do use some SQL queries that are generated either automatically or we generate them by hand, and we do other stuff against our databases. And only when we deploy stuff to production or to the big scale, it's the only times when we see whether things are going to work well or not, right? Things may break along the way, and because we are doing things in like testing environment, then we do not necessarily see those issues. We won't spook them, we won't catch them before moving. What we want to do in Metis is we would like to propose actually a better way, a completely novel approach to build database guardrails, so we can figure out that there are issues or that some issues with the databases will happen before we deploy to production. It's super crucial to push those checks to the left and catch them as early as possible. So let's actually go and see what could go wrong, and I can see we have a...
Sorry.
We make it full screen. Give me a sec there. Because the StreamYard broke everything with my mouse. So give me like that. It's full screen. Better now. Cool, we are back on Mac. Lovely. So before actually seeing, before going into application and doing the workshops, etc., let's see what problems we can see when we are talking about databases. The typical problem we have is like N+1 problem with the ORMs, right? We have a database, we have table called aircrafts. Aircrafts is connected like with the seats in one-to-many relationship. What we do is in top left corner, we have like a very simple application code that just loads all the aircrafts. Then we iterate over the aircrafts to get the seats. And what happens afterwards is, because our ORM can be configured to get the data in the lazily fashion, what happens is this generates N+1 queries in total. Why? Because we first get one query like select star from aircrafts to get the aircrafts, and then for every single aircraft, as we look through the collection, we send another query. The problem with this approach, there are actually two issues here. First thing is, we do not necessarily see that we have N+1 queries running behind. Only if we do not check what's going on in the database. Just by looking at the application code, the JavaScript code in this case, we don't see whether there will be just like one query or N+1 queries in total, right? The other thing is, this is depending on the configuration we have. We can be configured configure our ORMs to have like, to use just one query, if we configure it to go eagerly for the data. So we will have select star with left join, etc., right? So this seems like we can change that, but we don't see this configuration here. But even if we decide to change it to like eager fashion, then we have some other problems. For instance, imagine that I have this big aggregate root in top right corner, so I'm getting some users with details, peers, information, etc., right? This thingy will generate me a tons of like different joins here. And the problem is, this is actually the code I was running, or I was debugging in one of the production systems. This gets just one aggregate root. Why is it just one aggregate root? Because we do the word filtering with user ID 1 to 3, okay? So this should give us just one user, okay? But ultimately, to get this one user, because we join tons of tables, we end up with something like 300,000 rows being dragged from the database, pulled from the database to the application, so the ORM can transform that into one aggregate root. The problem with this approach is we won't spot these issues when we are talking about testing environment, dev environment, because in the dev database, we don't even have this many rows to generate like 300,000 rows in total, right? The problem is we'll get to this issue only when we deploy to production or when we go with like load tests that happen very late in our CI/CD pipe, right? This is the issue we may have. And also, just by doing like eager loading here, we can't solve this issue. So again, doing the configuration on the ORM level does not prevent the issue from happening, does not protect us from seeing issues like this one. Another thing that we may have is generally when we are talking about ORMs, they lack the visibility and introduce so many various things that we may miss when we are talking about the database interaction configuration and whatnot. For instance, database isolation levels. Do you know what your default isolation level is? Hands up. And I see no hands here. Do you know whether it's like read committed, repeatable read, or serializable? And this heavily depends on the database you use, but also on the ORM that you use. Some ORMs used to, for instance, change this setting. Do you know when your transactions begin? Do you know when they end? Who commits, who rolls things back, and whatnot? Do you know like about caching? Is the data cached by your ORM or is it not? Like, it is especially important when you scale out your application, so you have multiple nodes running your production system. And then if those nodes do use caching, then you'll probably get some like weird results because of the cache incoherence between the nodes, right? Do you know where is it configured? How is it configured? Just by looking at the application code, it's not trivial to answer, right? Whether those things are actually being cached or not. Same for connection pooling, same for query hits, same for triggers. Do you see whether triggers are executed, whether you have triggers in your databases? The same goes for migration, same for other things that are generally configured behind the scenes or are used behind the scenes, but we don't see them, right? Those are the problems that we want to tackle. Obviously, we could answer all of that if we have like a checklist of the questions we would like to answer, and if we go deeply through the configuration, through the production configuration, because this may also differ between staging and production, if we do load tests, if we verify whether our transactions are fast or not, etc., etc., we can obviously do that. The problem with this is we do it way too late. We do not have this at our hands as developers when we are writing our application. What we want to do, what we should do, is we would like to have a completely different approach, that we have database guardrails like built in directly into our developer experience and into our CI/CD pipelines from the very first step, pushed to the left as much as possible. So this is what we would like to achieve, and to do that, we are actually going to use Metis for doing that. So let us move on to the application we are going to use, to see how we can overcome those challenges that we have with ORMs, like changes in multiple places, scattered around the application, hidden stored procedures, hidden like functions, etc., etc. How can we make it better by using Metis? So let's move on to the packages. So I told you to download the materials. I hope you did. And let's now examine what we have in the package. I'll be using Visual Studio Code just to explore this package. Obviously, you can use whatever you have. So generally, this package consists of instructions, what to do during the workshop. We'll be doing these instructions one by one. And this package also contains a database, sample database that we are going to use. It is pre-filled with a couple of millions of rows, so we have enough data just to see what's going on behind the scenes. And we have two demo applications that we will be playing with. So the very first demo application, we are going to use something that is implemented using Node.js, Express, and SQLize ORM. But the general idea applies to anything. What we are going to use is just one particular setup, one particular HTTP server or database, but ultimately you can go with different things. You can go with with Prisma, you can go with Python instead. Over the time you will have more and more languages, SDKs, etc., generally to provide the same uniform experience, right? Let's start with the backend database. What I'm going to do is everything is provided as Dockers. And so to run Dockers, let me actually open the instructions how we do that. So let's move on to the step 1 HTML. What we are going to do first is we are going to understand the ecosystem, and you can follow along using those HTML files as I'm showing you. So the first thing we would like to do is we would like to start the application. So if we go to demos, Node, Express, SQLize, etc., there should be a README HTML file. The only thing we need to do is basically run the application using start service, okay? And this runs our backend application, and our backend application, I already have it running here. And backend application is super simple CRUD app. We are not going to do like extensive business logic, that's not the point for today. What we're going to do is just a super simple CRUD application that, for instance, is using a very straightforward service, for instance, to get the data from the database about the airports here. So you can see I am using SQLize ORM. I guess if you didn't use it, that's not a lot of magic here going around. The only thing which we are going to do is we basically need to import some entities, and entities in SQLize are defined in like this way, that I basically create a description of the table with data types and whatnot, right? And then I can use those entities to basically query my tables, right? So this is what I'm doing. I'm doing airport find all just to get the backend data. And the other application I have is the application Query Explorer that is implemented in Vue.js that I am also running here on the side. And when we open this application, let me just go to the proper URL. There you see it has one straightforward button with a couple of scenarios that we are going to run. So if I click show all airports here, you can see that it did extract the airports from the database. No magic at this point. The problem that starts is if I were to ask you, hey, folks, what does this application actually do to get the data? Will it scale? Especially that here we have some other scenarios. For instance, there is a scenario that we call show departures from airports, and its table scan of a big table, right? Would you figure out whether this thingy, if I run it locally, you can see it work like in a split second? Would you know whether it is going to run well in production or not? And this is what we would like to tackle initially. We have some code. Obviously, we could go to our backend service that is, for instance, something like flights, flight service JS. We could, for instance, check a code like this one, and is this going to work well? That's the case. That's the problem statement that we want to tackle. We do have application code, but we do not have the database observability and the database guardrails around. So what we would like to do is we would like to instrument this application using Metis SDK that uses open telemetry behind the scenes to get some actual insights of what's going on. So the very first thing I'm going to do is, and this is all described in the step 2 HTML, this is where we create the stuff and we instrument the application, so feel free to follow along. We go to Metis page, and what we would like to do is we need to create a new project. So I'm going to create a new project, let's call it like City.js. Let's create it. And when we create this project, what you see in this application is like, we have three important parts here. The one in the middle is about like our staging environment and will show us the activity of everything going behind the scenes. The one on the left is pull requests that we are going to use to implement a better and nicer CI/CD, and the one on the right is observability of the production databases. So I have an API key button here in the top right corner. I can copy this API key, and now my application is already kind of enabled to use Metis, and the only thing I need to configure is I need to put my API key here in the Metis API. However, in order to integrate with the application, the only thing we need to do is we need to basically go to documentation and copy a piece of code that configures everything from the OpenTelemetry. Do you know OpenTelemetry? Hands up if you do. Okay, seems like you do not. And so I'll quickly explain what's going on. So the OpenTelemetry is basically a modern standard of getting everything about getting the all observability of our applications. Like when we send an HTTP request to our application, get, put, post, whatever, we would like to see everything that is happening behind the scenes. And for many years, it was kind of hard. Logs were not standardized at all. There were no even standard HTTP headers for doing that. People were implementing various things, for instance, their own LAN port timestamps, etc., etc. And then a Cloud Native Foundation came up with this OpenTelemetry thing. OpenTelemetry is an open standard that allows us to instrument our applications on multiple levels. What we can see here in the source code is that we are instrumenting our application, for instance, on HTTP level, right? But we can also instrument like the database interactions, we can instrument every single part of it to get meaningful and standardized like way of exporting logs, metrics, traces, and whatnot. So just if we instrument every single part of it, what we can do then is we can figure out that this single HTTP call, for instance, resulted in this calls to the database or this calls to like external services, etc., etc. So OpenTelemetry is just a standard how to instrument stuff, okay? It gives you the SDK that you can utilize to build your own applications, for instance, Jaeger to visualize stuff or other things, to use this standard of exporting the metadata, right? And now your HTTP servers, they do integrate with OpenTelemetry, and they export this metadata. What we now would like to do, and what Metis does, is we introduce this completely new approach that we not only get the statistics like from HTTP, but also from the database, from SQL driver and whatnot. We call all of that, we connect all of that together so that we can see what's happening with the database behind the scenes. And let's see that in action. So I did copy the API key. I put it in the .env file. I do have this tracer. This tracer exposes one method that is called start Metis instrumentation. I just call this start Metis instrumentation here in line 4 when my application begins. What I would like to do now is I need to recreate my backend, okay? So I am going to rebuild the container for my backend, and then we'll see that this time this application, when it loads up, it will actually use the Metis and will provide us the instrumentation that we need. So let's give it like 30 seconds to download half of the world of NPM dependencies, and then we will see everything up and running. You can see that application is now back online. I can go to my Query Explorer, I can refresh the application, I can choose show all airports, and nothing changed here, right? You see, I didn't touch the business code at all. But now when we go to Metis data and when we go to our project, you can see that we do have some queries that were actually executed by my application behind the scenes. Some of those queries are like configuration queries, SQL statements that the SQLize or sends at the beginning to configure the database interaction. But you can see also this 304 get/airports, that is exactly this scenario I triggered here. So I click on this get/airports, and what you can see here, you can see that we do have those spans that I told you about, right? You do have, there was this get airports call HTTP call. that ultimately resulted in getting this, this one SQL statement that we can get and extract here. So you can see this is actually the SQL query that was sent to the database, right? So we can see just by adding this one line of code, integrating Metis to the platform, we get visibility on what is going on. Obviously, this is a super simple statement, so nothing like, let's say, groundbreaking yet. But let's actually do something more sophisticated. Instead of just getting the airports, I will now use the second scenario that is doing table scan of the big table. Okay? And what we have here, when I refresh this page now, you can see that, hey, there is another call that was to get flights departures from the AAQ airport as specified here. And you can already see it is marked with red, it has some critical high yada yada things. Let's dig into what happened. So when we open this up, what you can see on this screen is we have tons of different insights. So we have automated checks that are going to tell us, hey, is this going to work well in production? Basically, that's the point. Is it using table scan? Is it using indexes? Is it calling some functions in where filtering? Does it select star or other columns? Does it specify columns explicitly and whatnot? So we do have tons of various things that are automatically assessed at this point, and you can also get some statistics at your hand. For instance, that this simple query, and the query that we used here is like this one, you can see that this query read something like 200,000 rows in total, right? And you can also see that, hey, rows filtered is marked as critical. Why? What is the case? You can see that it did use a table scan to get the data, and table scan requires the database to basically go through all the rows in the table, right? Something we do not want because it doesn't scale well. So you do see the impact, and you also do see the remediation plan. For instance, it tells you that you should consider adding index and whatnot. We have various different insights here that check multiple different things. For instance, table scans, for instance, triggers, for instance, indexes, for instance, like I/O operations, sorting, filtering, etc., right? And obviously, as we continue working on this project, those insights will grow. We'll have more and more of them. Another thing that you can do is, this gives us this understanding of what's going on behind the scenes. If we go with those like tabs to the right, we enter some more, let's say, expert type of knowledge we get. So starting with SQL, you can actually like hover over like tables, and this should give you some details about like the tables which are executed, which things are actually scanned and whatnot, etc., etc. This gives you the SQL query, this gives you filtering, etc. We can also go to metrics. So you can see actually what was the total cost of the operation, right? You can see which things we used, what was the row size in bytes, etc., etc. Other numbers that summarizes what is happening behind the scenes and how those things are actually working inside in this given query. We can carry on with, for instance, the query tail. At least in this case, it's rather straightforward because we just got one operation just to sequentially scan the table. But later on, we'll see that we'll be examining some more sophisticated SQL queries, and we'll see and get some understanding of the actual database operations, how they are executed behind the scenes, okay? And we can also get the native execution plan provided to us by the database, or the list of the tables that we are actually using and what buffers we used, I/O caches, etc., to extract the data from the database. So this is all that we get. And now, how do we use that? We have seen that integrating this with our application was just like one line of code, plus copying a file from documentation. So it tells us that, hey, this thingy is critical. So we see that this table scan, this is a critical thing, right? What can I do now? Now I can tell, say, from the remediation plan that we should consider adding an index. And if we go to the backend of my application and actually to flightservice.js, you can see that I have another method here that is using flight index table. And this is something that I created on the side. I just copied the flights table on the side, configured an index on that. However, in your reality, in your real application, what you would do is you wouldn't touch the business code at all, right? You would just go to your SQL engine, SQL database, create index over there, and hope that it all works well. And this is where we would exactly miss the clarity, right? Because the the business code hasn't changed at all, right? But your query would now run way faster. You wouldn't see the change actually happening in your CI/CD pipeline. You wouldn't understand what changed behind the scenes. This handcrafted scenario only shows you that I am using like different table, but in reality you wouldn't. So you wouldn't see these changes. And this is what Metis gives you. Because now, if I choose this different scenario, so I choose the show departures using this index scan instead of the table scan, and I do get data. You see nothing changed here, obviously because it wasn't like a change in the business logic. And I go to my project, and now you can see that I have flight departures index, and you can see it has only one insight that is marked as like low issue, right? As opposed to critical high issues here. You open this up here, and this time you see that, for instance, this SQL statement is kind of the same if you were doing this real, because the only change would be in the index you would use. But if you now go to like tables, you would figure out that, hey, this time it was not a sequential scan of your table, but index scan here, right? So this is what you can get just by integrating with the Metis application. And now by dropping in this one single line of code, what we have is a full-blown observability, right? That's a good start. So now our application that I am running locally here, this is a very good start. We have an app that can perform and can send some spans that we see in the app and to the Metis platform, so we can examine that, right? Now, what we would like to do next is we would like to actually wire that up into the CI/CD process, right? This is what we would like to do. So the next step we are going to do is we are going to actually wire things Metis into automated tests, end-to-end tests, and the GitHub actions to see how this thing can help us when we are talking about pull requests, code reviews, and whatnot. So let's take a 5 minutes break. And after the break, we'll work on those GitHub CI/CD actions. And if you happen to have any questions, that's the right time to answer that. So we meet back at 3:50. We're back in line. So another thing that we may need to deal with is when we are actually doing deployments on large scale, meaning that if your application is running on multiple nodes and you can't replace these nodes atomically, I mean, you have 10 nodes. So you either deploy another 10 nodes and then you do the load balancing switch. If you don't do that, then you end up with split brain, meaning that part of your nodes are running with the old application, the other part is running with the new version of the application, right? So if your schema changes in between, that may cause multiple issues. Similarly, when we are talking about heterogeneous databases and heterogeneous applications, so we have various applications written, one in Java, the other one in JavaScript, etc., talking to the same database. Then we have issues like who owns the migrations, who triggers the migration, what happens if we add new columns, is it going to work well across this stuff, right? So generally we have various places where things may go wrong with databases, and we would like to see all of them when we are talking about CI/CD pipeline, and also we would like to get them analyzed automatically. So that's the idea, and what we would like to do now is we would like to introduce or integrate a nicely done CI/CD pipeline with our application, so we get Metis integrated in that step. So the very first thing I'm going to show you is if you go to this application, there is flightspec.js. So this is like a very straightforward end-to-end test here that you see that we are just calling this flights departures queue in our test, etc., etc. Also, what I'm doing is before running any test, I call start Metis instrumentation, so I also instrument the application using Metis in the end-to-end tests, right? What I would like to do now is I'm going to build a very straightforward GitHub Actions pipeline to build a CI/CD, and obviously this translates to whatever pipeline you already have, Circle CI, whether you use Bamboo, whether you go with Jenkins or whatnot, TeamCity, this is exactly the same, right? I'm going to just build it to show you how this can be integrated with GitHub, but the way you integrate with whatever application you have is obviously up to you. So we would like to open step-free HTML, and the thing it tells us first I need to go to GitHub and I need to create a new token that I will use for the Metis so it can comment on our pull requests. So we have some additional fancy features here. So I go to developer settings, I create new access token, I generate new token that we will call like seed.js. I give all the permissions to the repository, I generate the token, and bang, there we have it, okay? Now what I would like to do is, I would like to create a repository. So I will create a new repository for the application I'm running, and let's call it like city.js. I create this repository here, and what I want to do is, now I want to configure GitHub Actions. Do you know GitHub Actions? Hands up. Okay, half. So GitHub Actions is basically a very straightforward implementation of like CI/CD pipeline built in directly into GitHub. You don't need to configure your own, let's say, scripts. You don't need to configure your own nodes, databases, servers, etc., etc. You just provide a YAML file in which you explain what we are going to run in our CI/CD pipeline. And then GitHub will take care of that. We'll spin up hosts, we'll run the scripts, we'll do all the magic for us. So the thing I want to do is I need to configure those GitHub actions to provide a couple of environment variables that we'll use along the way, just like with our .env file. So I go to settings, then I would like to go to actions, and I'd like to go to the settings of the sorry, I went to the wrong place. I would like to go to, no, I want to go here, and I would like to go to secrets and variables and actions. What I want to do is, I just created a token in GitHub. This token Metis would like to use to comment on GitHub action, on your pull request, to add some insights that, hey, this pull request send this queries, etc., etc. So I create a new repository secret, and I should name it PR token GitHub. So I create secret with this given name. I copy the token, the one that I just created. I put it here, and bang, we are good. The other thing I would like to do is I would like to create two repository variables. One of them is the Metis API key, the same key I used throughout the application in previous step. So I just go to my .env file, I grab the Metis API key, I put it here, and we are good. And the other variable I need to use is I need to have an actual PostgreSQL database I'm running behind the scenes, right? For the purpose of this workshop, I do have a database, read-only database exposed in AWS, so I can reach out to it easily from my GitHub Actions. Obviously, in your, let's say, production-ready pipeline, you would have your own database, etc., etc. So anyway, I need to copy the database URL and environment variable, and here is the connection string. I just get it, I just paste it here, I add variable, and I'm good. Okay, so I have my GitHub Actions configured. Now what I'd like to do is I would like to extend my application to use those GitHub Actions. So first I will push the application code so that we can track the changes I'll be introducing, and GitHub can then run appropriate the actions. So I'm going to my git ini, to my backend. What I'm going to do now is I'm going to create the commit. I need to add the origin for Git. I'm not doing any magic here, just the regular stuff you probably do once, and that's it. And then I just need to push my changes and create a new branch with the changes I'll be implementing for GitHub Actions. Okay? Lovely. So we have it here, and it seems like it was all pushed out. Let's see whether I did it right. Yes, we have our files in the repository initial commit of what we have before. Okay. Now what I'm going to do is I would like to create a couple of GitHub actions that will trigger some magic for me. So first I will just copy these things, and then we'll see what I'm exactly doing. So the way you configure GitHub actions and your CI/CD pipeline with GitHub is in your repository you need to create a new folder that you call .github. And then you need to create a new additional folder that is called workflows, and then you create YAML files in which you explain what you would like to do in your CI/CD action. So you can see that I want to run some tests when I push my feature branch to the repository. So what I do is I have a job that runs tests on push, It runs on some latest Ubuntu machine that GitHub will provide for me. It checks out the repository code, so does git checkout, etc., etc., npm install, and finally does npm run test. Okay, that's it. That's all the CI/CD I need to do. If you use something like if you have CI/CD in your application, in your infrastructure, obviously this would easily translate to what we are doing, to what you are doing, right? So we are not building anything new here. We are just adding one simple step. And what is this one simple step? We just push the Metis API key throughout the test. I just add the Metis API key as an environment variable so that Metis can be instrumented. Let's carry on. I would like to add additional GitHub action that is going to run the tests on my pull requests and also capture everything in the Metis platform. So I copied another YAML file. What it does is it again checks out the repository code, npm install, runs the module, runs the test. But this time it also provides additional environment variable that tells, hey, this test that you run throughout this npm run test is part of this GitHub pull request, GitHub PR, right? And then we would like to also let the Metis know, hey, there is a new pull request coming on for this project. Please tag this pull request. So you can see that what we are doing here is we are taking some action from GitHub Actions Marketplace. So you don't need to write any code, you just ask GitHub, hey, there is some GitHub action provided by Metis, just take it, run it throughout this workflow, okay? We do it, and we also provide, obviously, database URL and other environment variables for Metis instrumentation. And what we wanted to do now is I would like to push these changes. So I added these files. I hope I didn't mess up with the names. I just commit, add, and push. Okay, new branch was pushed to the repository. So let me now go to the repository, and you can see already that, hey, changes branch has been pushed like less than a minute ago, right? This is the feature branch I pushed. I go to my GitHub Actions. For those of you who do not know how the thing works, the GitHub Actions in general, you can see that all your workflows are now triggered. GitHub automatically scanned your repository, found that, hey, there is a YAML file that specified that you would like to do something when you push to the repository, and then it runs this workflow, and you can see that, hey, it's running various steps that we configured. One of them was obviously run tests, and this run test is running these two tests that I specified in this flight spec JSON. And we can also now go to our Metis project. I can refresh the page now, and we can see that, hey, those two things that we run in tests are actually now captured in the platform. So I did run npm run tests, and you can see all the insights. You can even see the SQLized demo GitHub on push. So we can see this thing was captured automatically. But we can do even more. What we can do now is I can go to my repository, and what I'd like to do is I would like to create a pull request. So I'm done with my feature branch. Now I would like to share my code with the team, ask them to review. So I just create a new CT.js pull request. I created this pull request, I let it run for a bit, and you can see GitHub also automatically picked up all the workflows that we configured for this one particular pull request. So you can see there was already test application on push, but also there is also test application on pull request. Okay? This is this other workflow I just created. And you can also see that Metis is telling you, hey, we just analyzed your SQL comments, all the SQL comments that you run throughout your workflow, and you can get some insights about these comments if you follow this link along. So if I open this link, you can see that I have all my tests captured automatically here. And if you come back to main page of the project, you can see that there is this new pull request running up here. So what we can get is we now have the automated CI/CD that is showing you the performance, and you can see that, hey, this test that wasn't using the index is critical, etc., etc. Everything else is low priority in other fields. So what you can do now, if you wire this up into this application, what you can do is You share this pull request with your friends. Obviously, you configure it just once in your application. This is how we typically configure CI/CD. You use this with GitHub Actions. You can use whatever CI/CD later on if you would like to do. Some other CI/CDs will be supported as well. And what we have is not only you get the automated tests, unit tests, and checks inside the pull request, but you also have all these insights directly straight into your application. So just by looking at this, and obviously at this point what we have is we now have like the performance insights, we'll have the schema migrations insights, etc., analysis of your tables and whatnot, and you can immediately see, without going to any load test, that hey, this thingy might not necessarily work well in production. Right? So this is how we can do. And obviously, wired up directly the same experience as you have. And important to notice here is that we are not building any code in your application, etc. You just take what you have, plug in one method run Metis instrumentation, and then plug in one YAML step in the GitHub Actions. And we are good. And this is what we would like to have. Now we have a true proper database guardrails showing us that, hey, this thingy may not work well in production, and we didn't need to run any load tests, didn't need to go to production database, didn't need to do any special magic, just plug in a couple of lines, and we are good. So this is where we wanted to be, and now let's do a quick recap. So first, we integrated our application with Metis, and we see how to capture response. Then what we wanted to do is we wanted to improve our CI/CD pipelines to create this completely new approach of having database guardrails pushed to the left. Done. Now what we would like to do is we need to understand that things may actually break not only when we deploy them or develop them, but also after they get deployed to production, right? It may be that depending on our, let's say, peak traffics, whether what time of the day it is or what day of the week it is, we may have completely different requests coming to our application, right? We may have completely different traffic distribution, different edge cases, different even countries using our application and whatnot. So it's not only about developing the app, but also how to observe the production database, how to monitor how things work behind the scenes when we are already done with the deployment, and to quickly figure out and root cause all the issues when they happen in the database in production, right? So this is what we are going to tackle in after the break. So let's take another 5 minutes, and then we will go on instrumenting our production databases and observing how it works in production. So we come back. Okay, folks, so we'll carry on with another part. So, what we did is, we took our app, integrated it with Metis, used OpenTelemetry, we have full monitoring for observability of what's going on. We improved our CI/CD pipeline, now it runs on steroids, we see what's going on behind the scenes, we have automated insights, etc., etc. What can we do now? Now the thing is, we deploy to production, and it may be that even though we tested our app, we still have some bugs or inefficiencies or whatnot, but they do not manifest themselves like the very first minute after we deploy. Why? Because, for instance, if we were running a, let's say, video service, when do people watch videos? Obviously, Saturday evening, right? But if we are talking about logistics app or, let's say, ticketing application, when do people use our application? Mostly 6 to 8 a.m. and then probably something 3 to 5 p.m., right? Something like this. So depending on our peak hours or peak days, we may get completely different traffic distribution coming to our application, right? Let's take the video examples again. Like we'll have different videos available in the US, different videos available in Europe, in Australia because of licensing things. Right? So depending on the different content we serve, we will get, for instance, different genres and different queries coming to our application. So let's see how we can help this situation. When something breaks, we would like to get a nice root causing, nice observability and information that, hey, there might be an issue. So generally, if we were to classify problems with databases, there are 3 different big groups of problems that we may face. One of the problem is code changes. So we did change our application, did change our application logic. obviously JavaScript code in this example. So it resulted in running completely different select statements, right? Different queries going to our database, resulting in obviously different scenarios, different problems. For instance, schema changed, or we have a bug in our SQL statement now, and what? The other group of issues is schema changes. Something that we already briefly touched upon is that when we add new tables, new columns, change columns types and whatnot, we may actually cause our performance to significantly change just because, for instance, indexes are now inefficient, etc., right? So those things are related more onto the database. Now we have a nice way of observing what is actually going on behind the scenes and how we change the database, right? But the other thingy that is super important is query changes, in a sense, not that we change the query, the text of the query, but the query is now executed completely differently. Why can that happen? When we are talking about executing the query in the database engine needs to figure out how to actually get the data you are looking for. So, how to scan the tables, whether to use indexes or not, in which order scan the tables, in which order use the filtering conditions and whatnot. This depends on the thing that we call statistics, and this depends on the volume of the data we have. Statistics are basically some numeric values showing that, hey, this is how many rows you have, this is kind of the distribution of the data you have, this is how many null values you have in your database, etc., right? And these statistics heavily depend on the environment, obviously. You will have different number of rows in dev environment, different number of rows in production environment, right? And also, this is going to change over time, meaning that today your business runs with like 1 million rows in the database, but the following week it may be 2 million rows in the database. So statistics will change, and hence the performance and the patterns of how we work with the database will change. Another thing that changes is, for instance, locking and transactions. If you have just like one transaction per second, then locking is not a problem, right? But if you have like lock contention because you have peak hours and multiple people hitting your database, then you have completely different performance characteristics, completely different problems, right? Those things will manifest themselves in the production system, not in our dev environment. So we need to be able to observe the production database easily and monitor what's going on behind the scenes. What can go wrong actually, and things that can change, when we are talking about the queries, for instance. Let's say that we run a handcrafted query that the database can optimize for you. For instance, at the top I am using a query that uses CTE, Common Table Expression for short. The idea behind CTE is like I would like to extract the common part of the query to the, let's say, temporary table that I will use across. So what I'm doing is I'm running a handcrafted query that basically goes through all the boarding passes, calculates MD5 hash twice based on the ticket number, and then it does some couple of joins with filtering, etc. If I run equivalent query without the CTE, you can see the performance with around 8 million rows changes from 13 seconds to 8 seconds. This is something that either we can optimize manually, or this is something that your SQL engine may optimize depending on the content of your database, depending on the volume of data you have, depending on how you structure the data and what is the traffic and whatnot. So this can change. The other thing that we have is, I mentioned indexes quite a lot, right? Because, just as we saw in the first step, when we were doing table scan, Metis suggested, hey, you should add an index. Index, the way it works is when you create an index, it basically sorts your data on a hard drive, so that now when you are going through the index, you read the data sorted according to a column, right? And whenever you create a primary key typically in all the database engines creates a clustered index automatically, right? However, the thing is, the index may be also created manually. It may include multiple columns. You may define which columns and in which order. So you can create those indexes manually, and there are various types of indexes. Like the typical type we use is B-tree index. So we basically use a binary tree that is sorted so that we can do the binary search using this binary tree and we can extract rows faster, right? But there are also hash indexes. If we're talking about JSON B data, so storing JSON unstructured data in our SQL database, we may use specialized indexes for these scenarios and whatnot, right? So the typical answer, what to do when your database is slow, is just add an index. But what happens if you tell that to a junior developer? We end up with too many indexes. We just have more and more indexes, right? It's slow, let's add another index. But indexes are not free, okay? They do improve the query, the search performance, but now when you modify a row or you add a new row, you also need to update every indexes you have, like that covers this row, right? So generally, we shouldn't be indexing blindly, right? If we just add index more and more, we'll just kill the database, the same way as we are like killing it without adding the indexes, right? So what we need to do is we need to get the observability of the production system to understand whether our indexes work, what are the queries, how the traffic distributes, etc., etc. And this is what we would like to do, now. So what I'm going to do now is I'm going to show you a thing that we call Metis metadata collector. And metadata collector, let's open up another step. This is step 4. So what it does is it's a tiny component that we run in Docker, or you can run it any way you wish, but we provide a Docker doing that connects to your database and extracts some statistics about the database. It extracts, for instance, the queries that you executed. For instance, for PostgreSQL database, it uses pgstat statement extension to get the data, the queries that were executed, right? It also, for instance, extracts the indexes, the schemas, number of rows, statistics, etc., etc., anonymizes that so you can run it in your production environment, and it allows you to observe the performance of your databases. What I'm going to do is, the Docker I'm running behind the scenes with the PostgreSQL database is already like enabled to with this extension. What I now need to do, I'm going to run a new Docker that specifies what I'm going to do. So I'm using this public image of the Docker that we store in AWS ECR. I need to replace here a couple of things. For instance, I need to put the Metis API key here in the settings, and also I need to configure my connection string to this database. So I specify the connection string here, and what you can do, this is the command that I'm going to run. Now, the way it works is you run this Docker constantly 24/7, or if you are running this in AWS, then we provide a CloudFormation template that configures an ECS cluster for you. So basically a cron task that will run periodically. What I'm doing is, normally this metadata collector runs every hour. I'm now overriding it to run constantly because I'll be running it on local environment. And normally the metadata collector runs only some queries, like depending on different time of the day. Some queries that it runs like daily, some other queries it runs every like 6 hours, etc. Now I'm asking with this parameter to ignore this setting and to run all the queries automatically, okay? So I copy this thingy and I would like to start a new terminal. I type this command, I press enter, and let me run it. And you can see that, hey, it did connect, it did specify various things, and it printed out tons of logs. But what is important to us is if I go to my main page of the project, you can now see 2 additional things here. You can see that I have a new server that is localhost, and I can get schema analysis, for instance. And the schema analysis shows you all the tables that you have, right? And it also analyzes tables for you. For instance, it analyzes whether we have like how many rows we have, whether we have a primary key, whether we have like duplicated indexes, what's the size of the primary key, and whatnot. You can see similar insights as we saw for the query performance. Now we have for the database, right? This is the thingy. The other thingy that we have is we have the observability reports. So it's going to show you, okay, how many rows you have, what's the size of the table, how many dead rows you have, and whatnot. It also analyzes your indexes. This time it shows nothing because I just started it, and it will show you index statistics only after some time. So I will quickly move on to the demo project we have just to show you this feature. And for instance, the index usage would look like this one.
So you can see that, hey, we do have tons of various indexes. You can see their daily usage. You can see whether the index has no usage in like the last 14 days, etc., etc. You get that out of the box just by providing one connection string. Another thing is query statistics. For instance, you can see that, hey, this query was executed like multiple times, and you can see that this query changed performance from like over the time to like slow down, etc., etc., and whatnot. You can see your extensions, you can see your database configuration, everything in one place that quickly shows you what the production system actually is and how it works. So generally, the idea here is that you plug this into your database across all your environments you have, production, non-production as well, testing if you want, and you get a true nice and nicely updated statistics about the performance of your database. I also told you that we provide a CloudFormation template. So if you would like to run this, let's say that you run your stuff in or you have AWS infrastructure, then the only thing you need to do is you use CloudFormation to deploy this template, and this will create an ECS cluster that runs all the things like hourly, that cleans up afterwards so you don't pay a lot, etc., etc. And obviously what you can do is, if you want to figure out what this thingy is doing, because this thingy is something that we would like to run in production, right? Then probably you might ask, okay, what is this doing? Is it safe to be run in production, right? Does it anonymize data, etc., etc.? You can just go to like GitHub Metis metadata collector. It tells you everything: what permissions you need, what parameters you need to provide, how to troubleshoot this thingy, how much money it will consume, and whatnot. You can check the code, etc., etc. So feel free to just take a look at that. Obviously, you can run it from Docker, but if you are concerned about security, anonymity, etc., etc., it's all there, so we can go and figure out how it works. And after connecting it to your database, you get the full observability experience. And this is actually what closes the loop. So we started with the situation that we did have an application running, and we had no idea whether it's going to work well in production, right? We didn't know whether it's going to fail or whether it's going to succeed when we deploy stuff. We didn't know how fast it works. We didn't know what queries it sends, etc., etc. Now, just by integrating things in like probably 10 or 15 minutes once you are done with these workshops, you can see first the performance of everything you run behind the scenes. You can get CI/CD on steroids and get the insights. And ultimately what you can do is you can also get the production database observability, showing you how these things work behind the scenes and showing how your production system performs over time, right? So this is what we do. And now what we are going to do is, let's say that we integrated all of that with our application, right? We have everything in place, and now this thingy shows us that, hey, there are problems, issues, or whatnot. So now we would like to fix them. Obviously, Metis gives you some automated remediation plans, how to fix that, but what we would like to also do is we would like to get some understanding of how SQL Engine works behind the scenes, what it does, why it does the things that it actually does, right? So what we are now going to do is we'll quickly run through the last element of this workshop, which is CLI tool, and we'll also see how to reason about the database internals and how to figure out what is happening behind the scenes to get some better understanding and deeper knowledge. So whenever we actually execute a query, whatever SQL query, it goes through various steps, various phases of as it's transformed by the SQL engine. It all starts with the parser. So first we take the text of the query, select star from table, yada yada, and it needs to be parsed into some form that computer can reason about, right? Now, we know that some queries are equivalent to others. For instance, I can change the alias for the table name, right? I can change the alias for the column to some extent, and it's equivalent. So we would like to parse the query and rewrite it to some normal form that is like uniform, standardized, and the SQL engine can reason about, yes? Once we do that, here comes the most important part of executing the biggest part when it comes to performance, when it comes to executing the query. We create a plan. So SQL engine, typical SQL engine, I'm talking here PostgreSQL, Microsoft SQL, Oracle, and whatnot, it first creates a plan how it's going to execute given query. A plan that consists of information like which tables it needs to access, whether it uses indexes, if there are multiple indexes, which one to use, right? Whether if there are multiple tables to be joined, how to join those tables. Is it like nested loop join, or maybe it's using some sophisticated hashing logic, etc., etc. So some database engines even create multiple execution plans and then compare them to choose the best one, so the cheapest one. And finally, only when we are done with the execution planning, then we take this plan and run the actual executor. So then we go and get the actual data from the database. Now, what is a plan, actually? If I take a query, like the one on the left, you can see that I added this keyword explain at the top of this query, right? This is how you can extract the execution plan from your PostgreSQL instance. And you can see the actual, the execution plan on the right. And this execution plan tells you exactly what the SQL engine is going to do. Just by saying explain, I'm not asking the engine to execute the query. I'm asking it, hey, what are you going to do with this query? How are you going to execute that? So let's dig into and see what's happening here. So every single plan that we have consists on multiple nodes. Basically, more or less every row on this slide is a node of this plan. And those nodes, they have various multiple important parts. One of them is what the operation we want to execute. So you can see here at the bottom there is sequential scan, or there is bitmap heap scan, etc., etc. So those are operations that SQL engine tells us, hey, I'm going to read this table. For instance, sequential scan on the airport's data. I'm going to read this table using a sequential scan. So I will go through every single row, read it, do something with it. Then we also have some other operations like looping, filtering, ordering, joining, etc., etc. And we also have information like, for instance, that we want to filter using flight ID with this condition network. But the other thing, which is super important, is every node has a cost associated with it. So it tells us how heavy, how expensive the operation is. You can see that the cost is something like 6 or 128 or whatever else, right? This is an arbitrary metric that the SQL engine uses, and only SQL engine knows how to interpret that, but basically it comes down to something like, if this number, like I compare two plans, I compare their costs, I choose the cheaper one. That's basically the idea, right? Obviously, those numbers do matter to the SQL engine, so it can reason about these things, because it needs to come up with these numbers, need to assess them, estimate them, etc., etc. However, ultimately, the cheapest plan is selected. Now, those costs can be evaluated against various different dimensions, let's say. For instance, if I'm doing a nested loop join, let's say that I could use different joining strategy, for instance, merge join or hash join or whatnot. I would like to do, what I'd like to do is I would like to estimate how heavy that is and then choose the cheapest option for that. However, to do that, we only estimate the cost. SQL engine uses the statistics, so numbers showing how many rows you have, what is the index usage, whether the index usage is actually like in memory. Maybe my data is already in memory. Maybe I have some caches, etc., etc. How much data I would need to cache to execute given query, right? So those are various statistics that the SQL engine can use when planning how to execute the query. But then, when we actually start executing it, we may face the reality that we were wrong with this statistics, right? So how do we update the statistics and how does it happen? We can always ask our SQL engine to update statistics just to do something. For instance, here I can run a command analyze verbose in PostgreSQL, and it will go to every single table, scan it, update the number of pages, update the number of rows, update the number of dead rows, so rows that are not necessarily used anymore but are still stored in the data, update other things, and this is how we can refresh the statistics. SQL engine does that periodically, especially after we add a big chunk of data, but it doesn't do it all the time. Why? Because it takes time. This is heavy. To analyze your whole database, to rebuild your indexes, to rescan your indexes, takes time, and it's generally heavy, so we wouldn't do it like during our peak hours, right? But nothing stops us from running that like on Saturday night when we are off the peak hour traffic or what, right? Once we analyze those statistics, or once we have these statistics, we can generate two different plans. The plan on the left you see is the estimated plan. So this is the plan that we created based on the estimation of our statistics, tables, and how we would like to perform. Plan on the right is the plan for the same query, but this time it's the actual plan. So how it happened or how it worked when we actually executed the query. And you can see that we have some additional data in each node. For instance, we have actual time, we have the rows, how many we extracted, and whatnot. So let's actually take something like the second to last node here, and you can see that estimated plan said that we'll extract something like 156 rows, but actually we extracted 381, right? So if we have inaccurate statistics, then we won't be able to reason about those plans, and we won't be able to reason about this stuff. So how can we, now when we understand how things work behind the scenes, how can we use that to expand our knowledge and to analyze our database easily? And what we can do is, we can use the CLI tool, to basically explore our database. So, let me open step number 5. So, the last thing we have is we have a CLI tool that integrates with the platform and that allows us to do the ad hoc queries and to play with the database. So let's say that I would like to go to the CLI package. You can see there is a binary for the Metis CLI. What you can see is this thingy is like a CLI tool that provides a REPL mode. So you can see that it is like interactive, and if I, for instance, just press H, you can see that it's already like suggesting that, hey, there is a command named help, right? So if I press tab, what you can see is that it suggested what I would like to run, and if I enter help and run it, you can see how many various things I can execute. I can use macros, I can connect to databases, I can list tables, I can describe tables, etc., etc. So this is a great way of analyzing the stuff and doing ad hoc queries and observing what we have. So if I would like to, first I would like to connect to my database. You can see that I do not have any connection to my database. So first I would like to add a connection that I will call dev. That should connect to localhost on the default port, and the database name is demo. User is Postgres, so basically I'm using the database that I'm running locally. And now when I connect, you can also see that like this auto-completion works even with like dynamic parameters, right? I added connection named def. It already suggests that, hey, maybe I would like to use def. Lovely. So I connected to my database, it printed out some statistics for me. What I can do now, I can for instance do list tables, for instance. Hey, and this is all the tables I have in my database. If I go back to the script, what else I would like to do? I would like to describe the table, yes? So I can run describe table booking flights, and it's going to show you that, hey, those are the columns, those are the data types, those are the indexes you configured here. Everything at your hand, you don't need to go to Stack Overflow, how do I list the tables and whatnot. You have it working at your hand. But also what I can do is, I can run table analysis. So if I do table analysis of booking.flights, bang, it is automatically analyzing and providing me the metrics for indexes, for some statistics about like primary keys, whether they do exist or not, what the number of columns is, etc., etc. And ultimately, it also runs some automated insights on the table, just like that, right? The same thing that we observed with the query performance in step 1, later on with the database analysis when we were using metadata collector. Now you have it like automated here. Right? What we would like to do next is, when we have this CLI tool, when we have the CLI tool, what we would like to do is, we would like to connect it to Metis. Okay? So what I can do is, I can do set API key. I just need to copy API key, obviously, from my .env or the command I was using before. before. I can set the API key now, and what I can do now is I can, for instance, analyze queries. So let's see what I'm doing now. I would like to analyze the query select count star from booking flights. I would like to show the plan. I would like to show the explain. I would like to use estimated plan type. I presenter, and bang, it's doing me the magic. So you can see it's pretty bringing you the plan, the execution plan of what you have. It's going to explain you what operations we use, what is the cost, etc. It's running some insights for you automatically, and it also provides you a link that if I copy this link, or if I open this link, it points you to Metis platform. Hey, this is the query you wanted to execute, right? And you have all the insights here at your hand, telling you that, hey, this was an estimated plan, reading one table, this is how many rows we predict to read, and whatnot. So you can do that, you can mix it like either CLI tool or interactive approach, etc., etc. What we can do also, what we can do next is, if I go to my I can also use the actual plan, but we'll skip that. But what I can also do is I can now run some crazy query that is going to show tons of various things that I would like to execute against my database. So I have a really big select statement with tons of various joins, etc., etc. And you can immediately see that, hey, the execution query plan is now much more sophisticated, that there are multiple issues with this query. I can open up my Metis and it's going to tell me everything I had. If I now open the query tab that I showed you briefly before, now you can see that, hey, this is actually a much bigger thingy. It's going to use index scans, performance issues, etc., etc. You can see like IO buffers, miscellaneous data and whatnot. You can see everything that actually happened behind the scenes, right? Just with this one little command. But not only that, what we can do next is, what I was showing you until now is, I was just running these things in repo mode, right? But nothing stops you actually from running this thingy in like a very CLI tool way mode. Let me just open the script again. So I can, for instance, run this command just by, like from command line, and specify all the parameters from command line. So if I now do this thingy and I provide all the parameters, like use this dev connection, use this query, show plan, show explain, iPresenter, you can see things that it did connect to the database and printed out all the stuff. So if you wanted, for instance, to take the data we have here and we wanted to plug it into different systems you have, or different CI/CD, or maybe some automated reports or whatnot. You don't need to parse the Metis web page, obviously. You can, for instance, use the CLI tool to generate all the data you have and get automated things that you can use with other parts. So we can now see, based on what we just did with the CLI tool, we can see how we can close the loop and really have a good starting point to do everything. Database may break at any time. We know that, hey, there are ORM issues, there are problems with databases, problems with how we run the query, problems with missing indexes, with schema migrations, with the deployments. There are so many moving pieces around that can break the application that generally we need to be careful when we are developing stuff. Waiting for the issues to pop up in the production is completely unacceptable in today's world, right? But also waiting for issues to pop up in load tests is way too late for us. We want to push things to the left and check those as early as possible. We would like to be proactive, right? We need to understand that we need to have completely different approach of dealing with our databases. We need to have database guardrails that we run as early as possible, and we get constant monitoring, constant feedback just at our hands when we are doing the implementation. And Metis ultimately gives you all of that. Just by dropping one line of code and one file you copy from documentation, you can integrate your application and get all the insights as you are typing your code, right? You don't need to wait for load test to see whether this thing is actually going to work well. No, what you can do is you just have all the insights automated just when you run the queries. You can improve your CI/CD to finally get a true CI/CD pipeline that stops bad code from reaching production. And ultimately, you also get the safety and the observability of your production database that allows you to see what is happening in your live system. Not only that it shows you the problems, but does it also gives you the root causing mechanism, showing you that, hey, this is the query that was executed. This is the REST API code that caused the issues. This is actually the full trace of what is going wrong and how you can troubleshoot that and root cause that so you can figure out what the problem is. So, to summarize, we want to have database guardrails. We want to have them now, as early as possible, push all the checks to the left, and metrics gives us a learning end. Any questions? And by the way, I'm not following the YouTube chat, so maybe folks you could check if there are any questions over YouTube. And this QR code points to our web page. Feel free to take a look, feel free to read the docs, join our Discord, drop us a line, ask us the questions, also share your user stories and share your success stories, how you use metrics and how it improves the world, and everything around that. And being all of that said, I'd like to thank you for coming here. Hope you liked it, hope you enjoyed it. Join us in the conference, come to our stand, ask us any questions you wish, and let's stay in touch. Thank you.